Nice. And I'm back. I actually took a great nap, so I'm ready. I'm ready to do my thing today. So what will we do? Just a second. Just a second. Let me fix something. I'll be there in 2 seconds. Fantastic. Okay, so what will we do today, or what I will do, and you can follow along, is I'll wrap up these subsections on constructors and destructors. I'll start another section, maybe even two of them. Let me just see if I can. Do I think I can finish this whole chapter? It's quite a fat one, but maybe it's doable. Okay, so basically we'll go through a couple of chapters here. Okay, we'll go through a couple of chapters here. I might be even tempted to start a project. I first need to see if I have any projects to start a project code along on Python, because I think Python is more used than C. This is a nice hobbyist project, but it's not something that gives you good employment opportunities. So I might do this, and of course we'll do a lot of article reading. So it's 8 o'clock sharp where I'm from, and maybe if we are lucky, and I hope we are. Just a second. Maybe if we are lucky, we can do an hour of this, a good hour of this. So okay, let's start. So this morning I started working on I started writing these new parts, components of the code regarding constructing and destructing our new LWL objects, which are actually types of S expressions. So what we will do now is I will just create a memory releasing method. Do we have already something here? This is for printing. No, I don't think so. Okay, creating a new one from scratch. So I'm switching based on the type. I'll try to do this fast. So if we encounter a case of a number, I'll just break the switch statement. So we'll do nothing special for the number type. The other types. Now the other types. What do we have here? Error. We will just free the memory. Okay, I just copy this line. 1, 2. Can I copy the whole line? 1, 2. How do I copy the line? 1, 2. Can I just paste it here? Oh, I can. Nice. So in the case of symbols, I'm again freeing symbol. Nice. Now let's do another case in which we have S expressions. So, okay, let me try to do this on my own. There's a book, I'm following a book the whole time, but the best way to learn is actually to do things on your own. So basically what do we have here? If we encounter an S expression, so if we encounter an S expression and they are, let me just find them in the struct definition. So the type of the S expression is if the type of the LVAL is S expression, where is it? Where is it? Where is the constructor? It's here. So we assign a whole object and the type is S expression, the count is 0. So what we will do, I'm inserting stuff, right? Yes. So what we will do, I will iterate through all cells, and the length will be less than the count, e++, and then for every cell, I'm gonna call free on every cell. Okay. Again, this is just pseudocode. I'll write it now for real. Okay, for int e is equal to 0 is less than there is no length, right? We have count is less than count, and e increases by 1 every iteration. With this, we are iterating to every cell object in our structure, and then I'm calling, so I can't call free. Can I call free? No. I'm calling lval delete, so I'm actually calling the same method for every cell element at I. Okay. And I'm also freeing the memory itself. Breaking this. And then I'll free this as well. Okay, simple, but let me make sure I understand this properly. So, please explain this snippet of code. Why do we iterate through every cell and then free the cell as well? How does this behave? Give me a real example. Simple. Okay. Okay, this code snippets a function that frees memory associated with a data structure, likely representing a variant type in a Lisp-like language. This function is responsible for deallocating memory used by different types of LOL objects depending on the specific types. Okay, let's do this step by step. Okay, this is a signature. It takes a pointer to an LOL structure. Simple enough. So let me just connect my charger to my laptop. Second. Okay, hopefully it starts charging. It's stuck at 45 for some reason. No idea why. Let's do this again. Okay, it most probably will start charging at one point. So the switch statement checks against the type. Since numbers don't have dynamically allocated memory, no additional freeing is necessary. Okay. This is a string message, so this needs to be freed. This is symbol, this is freed. Now this is a symbolic expression, and cell is an array of pointers to other LOL structures. Okay. And V counts the number of elements in this array. For each element, okay, so all nested objects will be properly deallocated as well. After all individual elements have been freed, the cell array itself, which is dynamically allocated, is freed. Let's say, okay, we also have a real life example. This is the symbol, this is the numbers. When we call LOL delete on the outermost expression, it will iterate to every element in the cell. For the symbols, it will free the memory. For numbers, nothing will be freed because no extra memory was allocated. Okay, I understand it. It's a good explanation. Thank you, ChatGPT. Okay, let's talk about reading expressions. First, we are going to read in the program and construct an LL that represents it all. Then we are going to evaluate this LL to get the results of our program. This first stage should convert the abstract syntax tree to an S expression. And the second stage should evaluate the S expression using a normal Lisp rules. Okay. So we have step 1, which will be convert AST into an S expression. And the second stage evaluate S expression. Okay. Okay, so before I continue, how would we do the first step? How would we do the first step? So we would break the abstract search tree and we will construct an S expression. So here it says recursively. And construct different LL types depending on the tag and content fields of the node. Okay. Okay, I think I get it. I think I have it. I think I have it. Yeah, properly. To add an element to an S expression, we can create a function lvol_add. This function increases the count of the expression list by 1 and then uses. What's the difference between malloc and real loc? Okay, this reallocates the amount of space. This new space can be used to store the extra LL required. Using this new space, it sets the final value. Okay. So we have a warning box saying don't Lisps use cons cells. I have no idea what cons cells are. In most other Lisps, S expressions are defined inductively as either an atom, such as a symbol of number, or two other S expression joins or cons together. Okay, I didn't know this, and using linked lists might be a bit more complex. Okay. Now look at this. What's happening here? We are reading a number directly from the search tree. What is this one doing? What is the method and doing? Okay. Ah, so it converts a long, no, a string to a long integer. I don't know if the naming conventions in C are either real intuitive or not intuitive at all. One or the other. Okay, I don't need this many explanations. I know this. So what's happening here? If the error number is different from error range, we are creating an L1 num from the contents. Otherwise, we are creating an error here. Okay, so if we have a number or a symbol, we are just converting, we are using the methods that we created for converting the abstract search tree tag to the X expression. Okay. So what will happen here, I assume, is the following. Here we have, where's the, no. Where is the search tree? Okay. So actually what will happen, I think I get the gist of it. What will happen is we will create an abstract search tree, right? Which is a representation of our grammar. And then what we want is we want to convert this abstract search tree to an S expression, which I already written here. Okay. Easy. Okay, so this is the root. This is the root. I remember a couple of episodes ago I tried logging in the abstract search tree and I was worried because I get this weird element here, but it's a root, so it's a good thing. I know this now. Fill this list with any valid expression contained within. Okay, I go through the children I contents, if it is, continue, if it is, continue, if it is, continue, if it is, if it's regex, continue as well. Okay. Let's do this now. So there's no way of testing it until we go all the way through it. Oh no. Shit. Okay. So what will this be? This will be, and we are taking a search tree as a parameter. Okay. So if t equals tag, is equal to come on, bitch. Okay, is equal to number. But there's another way of writing this. It's string substring t tag number. So if it's equal to number, what will we do? We'll create, right? We'll create a numeric eval. Okay. Maybe I could write this method here. So eval read number takes the same parameters as this guy. Okay. So I'm converting this. I'm converting the contents of the abstract search tree contents field into a number, numeric value. Now, I have no idea how this works, but I'll just gonna write this. Okay. Invalid number. Okay. So now here, if it's a number, we can return this. So what I realized about writing code in C is that C is really simplistic when it comes to the structure of it. If the commands, if the keywords are sentences, then it's really easy to speak with C. What's hard is to speak proficiently, because it's a really complex language with a lot of gotchas and a lot of things that are specific to it and only to it. So if string tag symbol, same thing, return, create a symbol out of the contents. Great. Okay, so what if it's a root value? So if string compare t tag, so this is the root element in the search tree. If it's 0, right? What will happen? We are creating an empty S expression. Otherwise, if it's already an S expression, we do the same thing. Okay, simple and nice. So next thing is we iterate through the children. Fuck. Okay, we iterate through the children. We're gonna return X here. And we're gonna skip all the elements, string compare. Contents. Okay, so abstract search tree element. I'm going inside one of its children. I'm going inside the contents of its children. Okay. Equal 0. Fuck. Continue. Okay, and now we will just we'll do this. How to go to the start of the line in Vim? I forgot. I know that the $sign goes to the end, but 0. It's only 0. Okay. So 2, 3, 4. I think it's okay. Wait, what have I done here? This guy. This guy. And here we'll have regex, but instead of the children contents, it's going to be a tag. And then we are just creating this. Okay, nice, amazing. And next we're just gonna add these two elements. So we are increasing the count. Now we are gonna reallocate some memory. The size of lval times v count return v. Okay, that's it. Let's continue. Let's continue. No, we will do this later. But now I want to go here. We are now so close to try and go out of all of our new changes. We need to modify our print function to print out S expression types. Using this, we can double check that the reading phase is working correctly by printing out the S expressions we read. So I want to stop here before we continue. I just want to say the following. Like, I have a lot of question marks, but learning like this as you go and as you code is really helpful, because at one point I come and I see, this makes sense because back then we did these changes which are actually related to this. And I think this is the best way to learn, like just being thrown into the fire and fending it on your own. Printing out the S expression we read and verifying they match those we input. Okay, so what are we doing here? We are doing we converted the abstract search tree into an S expression. Now we want to create a method that's gonna print out our S expressions. I think we are almost done. Yeah. Wow, this is a big boy. Let's wrap up this subchapter as well on printing. Okay, so we need another method. So what is this method doing? It's a void method. It's a print method. It takes an S expression. It takes something which is an open character, whatever that is, and closed character, whatever that is as well. Putcar is a standard library function that's used to write a single character to the console. Okay. Okay, there is this. I have no idea what this does, but maybe I'll find out later. Okay. For each element, we have a count. We loop to the S expressions. And for every one of them, I'm gonna print them. V contents, is it contents? It's cell. It's cell. And so if it's the last element, don't print empty space. Okay, now let's create the real method. And I think both of them will be referencing each other. Okay, let's look at type. We'll have a couple of different cases. If it's a number, let's print. How does it work? Long integer is it like this? Yeah, it should be. Let's continue. If it's an error, what are we printing? Errors, it's a string. Break. If it's a symbol, the same thing. I think we'll print a string. Yes. Break. And now if it's a S expression, okay. So what are you saying here? I can declare this function because they call each other. So lval print is calling print expression. It's here. And this one is calling print. Yeah, they're really calling each other. The lval expression print function and vice versa. There is no way we can order them to resolve this dependency. So we'll do another C hack. We need to forward declare one of them. in our main loop, we can remove the evaluation for now. Instead, try reading in the results and printing out what we have read. If this is successful, you should see something like the following. Okay, I have a lot of edits to do, so okay. And I think that's it. This is the last subchapter. I'll do it later. But for now, let's do something else. Let's see what's new on Hacker News.